Hello guys, in this tutorial we'll be learning about a new electronic component called the ultrasonic range finding sensor. It is a sensor which is basically used for finding the distance between the sensor and any object that comes in the vicinity of the sensor. And we use this sensor commonly for making many small projects like object detection and an obstacle avoiding robot and so on. First of all, from the Tinkercad dashboard, we'll go to circuits, create a new circuit, and on the components, there is already a predefined component in the Arduino option. Go down and you'll find this. This is the ultrasonic finding sensor. Okay, now this sensor basically returns the distance between the sensor and any object in its range, and the range is actually 3 centimeters to 400 centimeters. You can observe that there are 3 pins, a ground and a 5 volt. The ground and the 5 volt is used for the powering up of the sensor, and there is an SID pin. This SID pin is responsible for the entire working of this sensor. So what the Arduino does is, here you can see that the SID pin is connected to the pin 7 of the Arduino. So the Arduino is used to send a digital pulse with a time of greater than 2 microseconds. So we send a pulse from the Arduino to this ultrasonic sensor, and this sensor when we put it in a looping function, this sensor will broadcast this pulse in its range, and when we place any object, this pulse gets deflected back from that object, and this sensor will get that pulse back. So basically the sensor does is that it will give us the time duration that takes for the pulse to go from the sensor and then get deflected back from any object on the range. So with this time duration, we can do some calculation knowing that the speed of sound is 340 meters per second. We can get the distance between the sensor and the object. Now, going to the coding part. Click on code, text. There is already some pre-written code, but we'll be doing a simplified version of this code, so I'll be deleting all of these. Okay, first of all, as usual, there will be the void setup, and the void loop. Okay, now we need to specify that the pin 7 is connected to the SIG pin of the ultrasonic sensor. For that, we give const in. Const is a data type of sorts which will specify that this variable will not change throughout the working of the program. And I'll call this the pin is equal to 7. Okay, now in the setup there's nothing much to give. We'll only give that the code for the serial communication to begin, so that we can use the serial monitor to print the distance of the object from the sensor. So we give serial dot begin at 9600 baud rate. Okay, now in the loop function we'll be doing all the basic functions in order to require to get the time from that pin. Initially, we have to specify some variables denoting to the distance and the time duration taken for the pulse signal. For that, we'll use another data type called long duration, and the distance in centimeter I'll denote it as centimeters. Okay, now we need to specify the pin mode. So now we have to specify this using the pin mode code to give the assign the signal pin to the digital pin. So for that we give the code pin mode pin as the output initially. First we'll give the pulse signal to the sensor from the Arduino. So initially we'll have to give it as an output pin. So we give it as an output, and then we give a pulse signal digital write pin as a low, starting from the low, and then we give a time duration delay of 2 microseconds, and then again we give digital write pin as high. Since this is a looping action, this will generate the pulse signal. We have to give the same code one more time, but we'll give a time duration of 5 microseconds here. Okay, done. Now this will generate the pulse signal from the Arduino to the SID pin. Now there is a specific function called the pulse in function, which is used for getting the time duration from the ultrasonic sensor, and for that we specify duration. Before that we are inside the looping function. First the pin is specified as the output pin. Why? Because we have to give the signal to the sensor, but after the signal is given from the Arduino, we have to receive the same signal from the sensor, which comes back after deflecting from any object. For that we'll have to again initialize this pin as an input. So I'll just copy this and then place it here, so that now we'll be receiving the input from the SIG pin, and we'll be assigning the duration as pulse in, which is a function pin, and we give pin along with what signal we have to receive. So the arguments in the pulse in function is, first of all, from which pin we have to receive the signal and what signal we are looking for. So we are looking for a pulse signal which is high. So in here we give high, and we get the duration of the signal after hitting any object in the vicinity of the sensor. And now we have to print this in the serial monitor. For that the code is but first we get the duration, and with some calculations we need to convert this into centimeters, and the calculation for that is centimeters will be equal to the duration divided by 29 by 2. Now the principle behind this is the sound signal has a speed of 340 meters per second, which is approximately 29 microseconds per centimeters. So we'll divide the time by 29, and this time is actually time taken by this pulse to go from the sensor to the object, and then from the object to the sensor, which is actually 2 paths, and we only need the distance, right? So we divide it by 2, and this will give the distance. Now we need to print it. So serial dot print ln, first we'll give as centimeters, and this is all the code. we'll give a delay of maybe 100 milliseconds. Done. And we'll give the simulation. Okay, now we need to go to the serial monitor. You can see some values are being printed here, and these values are in centimeters. Now, how can we see this distance using the software? I mean, if you're using the ordinary hardware, we can actually test it out by placing a pen holder or a bottle in front of the sensor. Now, for that, we'll just click code and then toggle this. Okay, now click on the sensor and you'll see this small dot like structure, and you can place your mouse pointer on this and then hold it and move it to any distance, and this highlighted blue area shows the range of the sensor. I'll just keep it here and then click on code and see. You can see that the value is changed. This is how we retrieve a distance of the object from the sensor. You can test it out by placing it at any distance. This sensor has many applications. There are many cool projects that you can build with this, like an object detection is most commonly used, and an obstacle avoiding bot. It's really cool. It's a really cool bot, and the way it moves, that we can place many obstacles in front of the bot and it will clearly avoid it if you are giving the code, if your code is very clean and you made the proper connections. And this is the basic concepts of this sensor, and you can tinker with this and maybe use this in any projects you want to build in the future. That is all for this video.